Hi guys, in this video we get back to the transition between textures topic. We're going to discuss a particular way to blend materials, especially useful when developing shaders for terrains. This technique consists in blending two or more materials by using their height data to generate the blending mask. To do so, we'll need a height map for every texture set we want to blend. A heightmap is a grayscale texture that, with each pixel, tells us how high the texture is, compared to a hypothetical ground level plane. To give you a better visualization of the data an heightmap represents, I made this shader that remarches and visualizes its values. This data, unlike the one represented by the normal maps for example, hasn't got a universal convention and its interpretation usually changes from game to game. For example, a game could consider the black color as a height of 0 and the white color as a height of 1. Another game could consider the middle gray value as a height of 0 and treat any value below as a depression and any value above as a mound. Moreover, a game could choose to have all its heightmaps normalized to take advantage of the full texture dynamic range, and then rescale them inside the shader. Another game could consider to define the word values of the heightmap color range and have it already in scale. As you may recall from the video about texture transitions, we already know that the heightmaps, to achieve our goal, must be used in some way as input for the lerp alphas. The base concept of height blending is that for every pixel, the higher height wins and gets displayed. So, we need a mask that is black when the first heightmap is higher, and is white when it's not. We can achieve that result by subtracting the first heightmap from the second one, taking the result sign and saturating it, eliminating negative values. The result is this mask which, when pinned to the lerp alphas, will give us result the intersection between the two materials. Now, to obtain a transition between these two materials, we need a gradient that lowers the one heightmap while raising the other one, and vice versa. To do so, we'll use the UV channel red component as example gradient. First of all, we will saturate and subtract 0.5 from it. Next, we are going to add it to the second heightmap and add its inverse to the first one. In this way, when the gradient is black, our first heightmap values range from 0.5 to 1.5, while the second ones go from negative 0.5 to 0.5, so the first heightmap is always higher. The value ranges are inverted when the gradient is white. Where the in-between gradient values are, the heightmaps have a chance to intersect. This is a good result, but we can do better. For example, we could want to be able to choose how smooth the transition from a material to another has to be. To achieve that, we have to slightly adjust our blending algorithm. The sign node must be replaced by a division by a smoothness coefficient, followed by an addition of 0.5. The height blending allows us to reach a higher quality in our landscape with relative simplicity, and it can be used in conjunction with other advanced techniques, which will be discussed in future videos.